Imagine a world ruled by straight lines and right angles. Well, you don't really have to imagine it because this is the world of math that you've lived in until now. This world is called our Cartesian coordinate system. It's basically what you get when a graph paper and a brick wall have a baby. And let me just zoom in on this graph. So there we go. And let's just say we have this point 3 comma 4, which means go 3 units to the right and 4 units up from the origin, and that's also known as the center of the plane. It's basically like the MVP of the system. Now that's all good and well, but in Cartesian, everything is strict. Left or right, up or down. Rotation, forget it. That's illegal. You try spinning your point here, and math will call the cops on you. And this is where I introduce you to a whole new world. And no, I'm not talking about Aladdin. I'm talking about the polar coordinate system. Now, in polar coordinates, every point is written as r comma theta. That's this weird little kind of circle thing with a line through it. Now, r is the radius, that's how far you go from the center. Theta is the angle, how much you spin from the positive x-axis, that's measured counterclockwise. So, like this. So instead of go 3 steps to the right and 2 up, or 3 steps to the right and 4 up, Polar says spin this much, walk this far. So let's graph 5 comma 60 degrees. Your radius is 5, and your theta is 60. Well, yeah, 60 degrees. So you start at the origin, that's your dance floor center, spin counterclockwise 60 degrees from the positive x-axis, walk 5 units forward in that direction, and boom, you just plotted a polar point. Now, if you want to graph fast, you gotta know the VIPs of the polar party. These are called benchmark angles. And so these are just a list of them. There's 0 degrees, that's facing right, positive x-axis. Then there's 30 degrees, that's slightly tilted up from the x-axis. 45 degrees, that's a perfect diagonal upright. Then 60 degrees, that's steeper diagonal upright. 90 is straight up. 180 is straight left. 270 degrees is straight down. And 360 is a full circle back where you started. Now, if r is negative, you don't panic, you just moonwalk in the opposite direction. For example, -4 as your radius and 45 degrees as your theta just means face 45 degrees but walk 4 units in the opposite way. You'll land at the same spot at 4, 225 degrees. And there you have it. Remember, polar coordinates are all about spin first, walk second. Use those benchmark angles to make plotting easy, and don't freak out if the radius is negative, just walk the opposite way. With a little practice, you'll be graphing points like a polar pro. Keep spinning, and I'll see you in the next video.